Welcome to this course on resultant force. This course is brought to you by the Formation Professional Private Limited. Okay, I'm going to start off with Newton's second law of motion. Now, this Newton's second law of motion states that for an object of constant mass, the resultant force acting on it is simply equal to the product of its mass times the acceleration. And take note that the direction of the resultant force is the same as that of the accelerations of the object. Okay, this is a very important formula that all of you need to know. F equals to ma. F stands for the resultant force or the net force. Now the SI unit for force is Newton. Okay, m stands for the mass of the object and it is in kilogram. Right? A, as the letter implies, it means the accelerations of the object, and the SI unit for acceleration, meter per second square. Okay, before you proceed further, you need to understand the definitions of Newton. So 1 Newton is essentially defined as the force required to produce an acceleration of 1 meter per second square in a body where the body has a mass of 1 kg. Okay, let's look at some example. Okay, this example 1 says that I have this boy, he pushes a large box, the mass is 5 kg. The force applied is 20 Newton, so find the accelerations of the box. So if you're going to ignore all opposing forces, we're going to apply F equals ma. So the force is 20 Newton, which is this applied force. The m is 5 kg, which is the mass. So F equals ma. Sub in the force as 20 Newton and the mass is 5 kg. You can actually find the accelerations to be 4 meter per second square. Okay, another example. You have a car, the mass is 1000 kg, accelerates from rest to 20 meter per second in a time of 5 seconds. What is the forward thrust of the car? Now this forward thrust essentially is a type of force. Alright, so let's see how we tackle this question. So first of all, we write down the information given to us. M stands for the mass, which is 1000 kg. We can calculate the accelerations by using the accelerations formula, v minus u over t. So 20 minus 0 divided by 5, you get the accelerations as 4 meter per second square. So applying F equals to ma again, you have the force to be 4000 Newton. Okay, this example 3, the force on an aircraft with a mass of 725 kg is 15,000 Newton, which is here. Air resistance 9925, right, which is the opposing force. So find the accelerations of the plane. So the first thing we do is to determine the resultant force. Okay, this is the resultant force, or we call it the net force. Right, take note, this 15,000 Newton is not the net force. Okay, this is not the net force. With the mass of 725 kg and applying F equals to ma, you will realize that the acceleration is 7 meter per second square. Okay, a case of Newton's second law of motion, F equals ma, is due to that of gravity. Okay, you look at this formula here. W equals to mg. Weight is equals to the mass multiplied by the gravitational acceleration. So this weight is a type of force. M is obviously the mass. G is the acceleration due to gravity, which in this case is actually the value of A. So if we have G to be 10 meter per second square, what is the weight of a 1 kg mass? Essentially the weight is just 1 kg times 10, you get 10 Newton. So essentially 1 kg is equivalent to almost 10 Newton. And if you have a weight of 550 Newton, what is the mass of the girl? You divide 550 by 10, you get 55 kilogram. Okay, finally, we'll look at friction. So in this case, I have a box pushed with a force of 20 Newton and a frictional force of 5 Newton acting on it. The box has a mass of 10 kg. So draw the force diagram to show the forces acting on the box. So you have 20 Newton, think this way, and you have the friction, think in the opposite directions, 5 Newton. Okay, what's the resultant force? So you take 20 minus 5, you get 15 Newton. So that will be the resultant force. You want to find the accelerations of the box, apply F equals to ma. So you have 50 Newton is the resultant. The mass is 10 kg. Then multiply by a, which is the acceleration. So in this case, you'll get the accelerations to be 15 divided by 10, and you will get 1.5 meter per second square. Okay, this is the end of the lecture. Thank you for your attention.